just a little bit, but all the leaders answered correct.
What about the leaderboard?
Who was the fastest now? Who gets the first place? There should be no big changes, definitely.
These are really nice actually for training materials like what we're doing right now. They're also really nice to share.
So now I'm going to the UI, getting started with UI. I will do the npm install.
As a beginner, I would say this was very useful to understand the feature of Cassandra.
I'm really thankful to the organizing team.
The 8-week journey was wonderful and each week was equally exciting.
Hello everyone. Hi Eric.
Hello, good morning, or good afternoon for you, I suppose.
Yeah, well, that's pretty good evening to me, but that doesn't matter because we are definitely going to run this Monday show for everyone who is together with us. So if you can hear us, if you can see us, please set the thumbs up in the YouTube chat so we can proceed. And I see people are joining, and that's great. That's a little bit funny, you know. We run this show twice per day to cover different time zones. And it feels very interesting. We are kind of following the sun as more and more people are joining from different regions. Isn't that great, really?
Yeah. Yeah, no, that's good. That's probably one of the advantages to running it twice versus just a single time, so.
Exactly.
Let's see. Got 19 in YouTube chat, and that number is going up.
Yeah.
Welcome to everyone who's just joining us here. I got a thumbs up in the YouTube chat there. I think we're good.
Hi, Chris. Okay, so let's start. And we have to say a couple of words about what's going on for everyone who is joining us. Today we have no Menti, so I will not ask you how many of you are with us already and know what the DataStax devs is and what are our workshops. But that's okay. And let us start. So that's Terraform It or Terraform IT. Both names are perfectly valid. Infrastructure as a code. And that's Aleksandr VOLOCHNEV and Erick ZIETLOW, together developer advocates at DataStax, DataStax Devs, DataStax Monday Learning. What is DataStax Monday Learning? That's from engineers to engineers about most important technical and software development topics, absolutely for free. Talks, workshops, and whatever you would like to have. We want your Mondays to be the best day of your week, so we run this DataStax Monday Learning to help you upgrade yourself, unlock new skills, and become a better developer. Welcome.
And they're also on topics that we just want to talk about too, that things that aren't necessarily databases or our day-to-day. So, you know, interesting topics.
Yeah. If you are with us first time, you maybe don't know our other projects. We have Cassandra Global Meetup, which is also very interesting, about advanced topics for Apache Cassandra. And we have also Cassandra workshops regarding Apache Cassandra and the whole ecosystem. Cassandra plus Spark, Cassandra plus Kafka, and all the other things like that. But this is the DataStax Monday Learning, and today we speak about infrastructure as a code. And by the way, I'm happy to announce the next workshop in 2 weeks. Our guest speaker will speak about Ceph. That's high capacity distributed storage. It feels very native to us because Cassandra is a distributed database and Ceph is a distributed storage. So for different kinds of data, that's also very interesting for everyone who wants to be able to handle any size of data. Just 2 words about myself. I'm Aleksandr VOLOCHNEV, developer advocate at DataStax, professional cloud architect, developer advocate, and Monday Learning program editor. So very happy to see you on all of our workshops, and please subscribe to us at LinkedIn because there are more announcements and more interesting things to come. Eric?
Yeah, I'm Erick ZIETLOW. My intro is a little shorter than Alex's. I'm a developer advocate here at DataStax. I'm basically just a technology enthusiast. I tinker in my spare time. I've worked with a lot of different companies out there, helping them to get their stacks up and running, especially on top of Cassandra. So kind of a lot of experience on, or I should say, a little experience on a lot of things.
Sorry, everyone. Eric is maybe too shy. I can say what he's doing great workshops and converts complex data in a very understandable pieces of information, like we all have seen at the recent KubeCon. I mean, maybe not all of us, but if you are interested into Kubernetes and Cassandra, you definitely want to see our latest workshops completely prepared. Well, maybe not completely, but 95% prepared by Eric, I would say. I was mostly on the infrastructure side of things. Okay.
Infrastructure is important too, as we'll discover today.
Yeah, perfect. Okay. So, and there are multiple things for you to consider during this workshop. First, video and video streams. Our main primary channel is the YouTube DataStax Devs. Mostly probably you are watching it right now. We also stream on Twitch at DataStax Devs, but that's a backup channel, so we don't answer comments at the Twitch comments. Don't feel yourself ignored, just jump into YouTube channel. Or better, Discord. We have a Discord server, Fellowship of the Cassandra Rings. It has like multiple thousands of people actually in, which is great. And when stream is over, chats will be gone, but Discord server stays forever. So you may want to ask questions where it will be much better place to talk about different things.
And I'm dropping links in the YouTube chat for our Discord there. For anyone who's interested in joining up there, just go ahead and click that link and it'll take you right there.
Thank you. And then we publish all the materials for this workshop at our GitHub at DataStax Devs. They are not published yet. I'm sorry, but I'm to publish them immediately after the workshops. It's all prepared, so we are going to have them in the moments. Well then, and finally, our runtime tool for today is Terraform. That's a great tool. I love it. It brought some pain to me in the past times, but I still like it, you know. That's like long-term relations. They sometimes have some pain in them, but that's still a lot of love, let's say. And today we speak about infrastructure as a code. And you know what? I don't like formal definitions from Wiki. Infrastructure as a code is the process of managing and provisioning computer data centers through machine-readable definitions files, rather than physical hardware configuration or interactive configuration tools.
It's a lot of words just to say it's a script file that deploys everything for you.
Kinda. So we will see it later during this workshop. Maybe we will find a better definition. So I don't want to bother you all with long stories about how it was before, because mostly probably you know. If you want to have a new server, then depending on the situation you have, do you own your own data center, or are you using colocation or buy rent servers from hosting companies? That's still, in the best case scenario, you have a web interface. And even using web interface, in some cases you have to wait for days or even weeks. I'm not kidding. If you are a new developer, kinda like just join it, the community, it was for real like that. But in some cases, Especially if you need some specific hardware, you have to order new hardware for months in advance. And that's not a joke. And that's all a long story. The main downsides from my point of view, what we will mention today, it's nearly always very slow and it's never flexible. It means what, like last Friday we have had this Black Friday, is it correct, Eric?
Yep, that's correct. And Cyber Monday today, so
yeah,
still going on.
And you see, when you can't change your infrastructure flexible enough, you overpower it during the whole year to just cover the higher demand on the Black Friday, Cyber Monday, and whatever. Or you don't waste too much money on the idling servers during the year, but on the high demand time, like Christmas times, Christmas gifts, or Black Friday, you are deep in troubles because your infrastructure simply doesn't answer the big demand on your application. Then something has changed, and that's an interesting point. 10 years ago, chief officer, I don't remember what was it exactly, of Oracle. Who was that exactly? One of the chief officers from Oracle said what cloud computing is complete gibberish. Is like that something just a buzzword which will disappear in a year. Since then, only AWS, main cloud provider, has finished 77 availability zones, easier speaking data centers, and plan to build 15 more. And that's not counting companies like Google Cloud or Microsoft Azure and many others. So there is a huge demand in this story, and you know what? Those are big data centers.
Yeah, and you know, it's funny too, because since he said that, the entire internet has pretty much migrated to cloud.
Yeah.
I mean, AWS itself is responsible for a massive percentage, like 60 to 70% of the websites you visit on a daily basis are probably hosted on AWS. So it's just kind of mind-blowing when you think about it.
Yep, exactly. So what are the key features of the cloud computing and clouds? And you may be curious about why they are talking about that right now. You will soon find the answer. So, first, there are a lot of different opinions. I prefer to build my own list out of the available principle, the list of most important features for the clouds. First, it should be on-demand self-service. You shouldn't call by phone a manager of a hosting company. It should be one-click button self-service. You need that, you get that immediately. Then, rapid elasticity. Earlier this month, together with Eric, we did a workshop at the KubeCon, biggest conference for everything what is Kubernetes related, for Cassandra, that's special ecosystem Cassandra in Kubernetes. Very great project, and it had a huge interest, like really a lot of people attended the workshop. Altogether, we were running around 1,000 test training servers for everyone to be able to work with the system without installing it all on their own laptops. And you know what? At the day before workshop, just 2 hours before the workshop, we had 0 instances deployed. When we pushed the button, we got our 1,000. We gave them to the users, and 24 hours later, when the grace period was over and workshop is done, we again, boom, 0. Rapid elasticity. We want to have more, we get more. We want to have smaller numbers, we go with smaller numbers, and that's not a question, it's just one button pushed. Then, shared resources, or more scientifically, resource pooling. It means what you share resources with our clients. In most of the cases, you may demand something more or less dedicated, but most of the cases we speak about shared resources. It's both good and bad. Why good? Because it's cheaper, and therefore you may charge less prices from your clients, your price is better, blah 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 blah. but also, yes, noisy neighbors may bring some troubles, exactly like in real life. Noisy neighbors are always the worst. Then,
oh yeah, and we saw that a lot in production too with Cassandra systems when they'd be running and you'd have a noisy neighbor on, say, like AWS or maybe Azure, and suddenly you've got one node that just isn't performing and you're wondering why. Well, it's a noisy neighbor a lot of the time.
Yeah, that's understandable. Well, many companies are using dedicated servers, even with clouds, and many companies now, like with AWS Outpost project, they run, that's incredible. Have you heard of AWS Outpost?
I haven't. No.
Oh, that's a cool one. That's like you have your own hardware and you set it up to work together with AWS and you can use it on your own hardware. That's pretty cool.
Interesting. So they give you a deployment package, basically.
Yeah, so that's like on-premise, but not on-premise. That's interesting. But okay, not about that. Then, very important thing, we will speak a lot today. API, Advanced Programming Interface, Programmable Access. And that's very important thing for us, so that's we are going to use a lot today. And finally, pay as you go. So you pay for the resources you consume it, not the resources you are signing on, then you rent and come server for multiple months, like it was before. And today, therefore, we speak more and more about APIs. We don't make phone calls and send mails. More and more often we get our servers when we need them using API calls. That's like you may require to launch a new server from AWS just using basically a cool request. It's maybe not so obvious because there are some authentication and other things, but that's what done by AWS client. Simple HTTP call. Second thing, what really helped us all is software-defined networks. That's all about simplification of networking, so we have to pull less wires, and that's great. In short, today we still use web interfaces to grab a new server, but also API calls to get what we need. And now we are getting to interesting point. I'm speaking about clouds and you may be, okay, Alex, what's the infrastructure as a code? Enough talking, let's get to the topic. In just a moment, you will recognize why I told you everything what I just told. But before that, I have a question to you. Have you ever happened to use Docker and Docker Compose? Notice and.
Yes, I know where you're going with this.
Yeah. My point is very simple. You can answer in the chat. That would be pretty interesting if you have used it or not. So we will know proportion of the people using them or not using them.
See, it looks like a lot of people are responding yes. Cedric with, Alex, what is infrastructure as code? Cedric, go sit down, be patient, we'll get to it. Okay.
Thank you, Cedric, for being with us. By the way, let me introduce you, Cedric Lunden, Director of Developer Advocacy at DataStax, directly in the chat, answering our questions. Okay, so take a look. We have yes. And that's great. That's very interesting. Because when I may have something special to you, you already using infrastructure as a code. And I'm not kidding. That's for real. You already using infrastructure as a code. How come? Let's take a look. If we talk about Docker and Docker Compose, Docker client is a simple console command which calls API methods of Docker daemon via HTTP calls. So in general, simple calls, simple communication via simple calls. Your Docker client may be installed locally but work with a remote Docker daemon. Your Docker client may work with a locally installed daemon. It's not the point. There is a client application and server application or daemon application. And when you execute a command in your console, docker run -p 8080 to open port nginx, just for an example, that goes as a system call to Docker client, and then it goes as an HTTP call to Docker server. So far so good. I'm just repeating the obvious thing you may know already. But then comes one extra step. Docker Compose. Docker Compose reads configuration file and runs appropriate Docker commands. With Docker Compose, you don't do Docker commands, but Docker Compose do that for you. So you describe your configuration or system of running services, of running Docker containers you want to have, and say Docker Compose up. Docker Compose reads the configuration file and executes proper Docker commands via Docker client, which makes HTTP calls to API of a Docker server. And that's exactly how infrastructure as a code works.
Yeah, it's basically a giant recipe that specifies your entire setup. So if we were running Nginx and we had a bunch of other microservices, for example, we could put all of that into a Docker Compose file with all of the right ports, all of the right endpoints, and just Docker Compose up, and it stands up that entire multifaceted microservice infrastructure with one command. So really, really cool. It's a recipe that bakes your infrastructure for you.
Yeah, exactly. And if we look at the Docker Compose file, so Docker Compose config for the containers you want to have running, we start to understand what that's our infrastructure. Infrastructure as a file or infrastructure as a code, where we have everything described. And there are two main approaches to describe your infra you want to have. Containerized infra in this case, and we will get closer to the virtual machines in a moment, but there are two main approaches: declarative and imperative. With declarative, like in this case, we don't tell what to do. Run this container, run that container, set this environment variable. But instead of that, we explain what we want to have in the end. So this approach is declarative. We declare, I want 2 services, 1 WordPress, 1 database, and I need them to be configured this way, but we don't tell to Docker how to configure them. We just tell what we need. And imperative approach is a little bit different, because where we say exactly how to do the job you want to be done.
Right, it's more like a script file that goes through all the individual steps at that point.
Yep.
Versus the description of what we need in the end.
Yep. And that's the, well, what we have is the description. For example, it doesn't matter if WordPress describe it first or database describe it second. WordPress depends on the database, so database service will be created first, because it's not a script, but the definition. And when, as we have a file, we need something to do API calls for us. And as said, that's just an HTTP API calls we can do with AWS CLI, but we also can do with curl, or we can do with Terraform. That only important what Amazon AC2 or any another cloud provider supported by the tools you are using, you will see in a moment. Just provide proper API methods. Create a new machine, pause machine, terminate machine, do something more, and so on and so forth. So as we call with AWS CLI API methods on Amazon EC2, and then Amazon EC2 can spawn new instances for us. That's exactly the same idea. So, speaking of tools, there are plenty of infrastructure as a code tools doing those process. Get the definition file, or maybe imperative script file, depending on what particular tool we are speaking about, and read that and calculate some things. You will see in the process what exactly and does the API calls to build your infrastructure for you. So we can group those tools into 2 big groups: vendor specific or multiple cloud support. And it's a little bit complicated question. because, for example, we have AWS Cloud Formation, which supports AWS only, but very good, but only AWS. And we have Cloud Deployment Manager for Google Compute Platform, which is again vendor specific, works only with GCP, but does it very good. As soon as you have new service, it's already supported by Deployment Manager. And from another side, we have multi-cloud support tools like Terraform or Pulumi. Those are multi-purpose, let's say, so they can work with multiple clouds. But as it's the community tools, there may be some solid, sometimes pretty long delay before new features implemented by vendor, by cloud provider, will be also supported, for example, by Terraform.
Yeah, it's all based on what APIs are offered, basically. I mean, if there isn't a call to perform that action, then you're not going to be able to do it.
Yep, of course. And that's one more point to mention. There is big discussion if to call Terraform vendor agnostic or not. Some people say it's vendor agnostic because I can create with Terraform, I can create cloud, I can create instances at AWS, Azure, and GCP at the same time, and that's correct. But meanwhile, file definitions we will use will be different, and you will see it very soon. So I'm still not sure if we should call Terraform really agnostic. That's not, you see, we have Apache Cassandra, which is cloud agnostic. You can run it everywhere, and it doesn't care. With Terraform, you have to understand the cloud you are working with. So that's for you to decide in the end. I don't want to push you to any of the names. And our hero for today is HashiCorp Terraform. It's an open source infrastructure as a code software tool created by HashiCorp. Users define and provision data center infrastructure using declarative configuration language using a HashiCorp configuration language, HCL. It's in active development for already 6 years. It's declarative as said, and it supports nearly everything what provides API. I mean, you may be now laughing at me, what do you mean anything? But let me show you a thing.
It's everything.
Yeah, I'm going to the registry at ter.terraform.io, and here downstairs you may see some numbers. 574 providers and 4,543 modules. It means what from the providers count, it supports literally, well, maybe not literally everything, but a lot. I'm very curious why it opened so slowly today for me, but as long as you can hear me, it's okay. Okay, it was, it's adaptive.
It's basically how many platforms they support, and the models are how many different pieces of those platforms, like sub pieces of those platforms. So it's huge. It's massive. It's yeah, Oracle Cloud Infrastructure, Azure, AWS, basically Alibaba Cloud. You've got all of the big names there. And then when you start getting into the later pages, you've got a lot of smaller providers as well, you know, more obscure. And it's basically, I think their mission at Terraform, from just the reading I've done and the poking around that I've looked at, is to kind of support the world. They want to be able to do literally everything with Terraform.
Yep. Notice Grafana. You can define Grafana with Terraform and so on. So basically, you can define nearly everything as long as it supports, provides API. You can write files for that to be converted, and those APIs will be called. There is a problem. There is an important problem to understand. Not every API is rich enough. For example, 4 years ago, when I started to use Terraform, my company, former company I was working at, we were using OpenStack and we were migrating to AWS. But a main part of infrastructure were on OpenStack. And it was really well supported, and it was nice to use it with AWS, but OpenStack was hardly supported at all, and we got really a lot of troubles trying to manage OpenStack with Terraform. It was 4 years ago, and it was only 2 years after the project creation, so I think now it's much better. But not all the providers are supported at the same level, but you know what? As we always say, it's an open source. If you are not happy, go develop something better. Okay.
And then let us know so we can showcase it.
Yeah, so we very happy to have guest speakers at Monday Learning, do you know? Good. So, well then, we discussed already Docker Compose and Docker. And it goes exactly the same with Terraform. So you also have Terraform files where you describe your configuration. For example, here on the right side, we can see some definitions. And that's exactly how HCL, HashiCorp configuration language, looks like. So at first you have resource, and that's how every definition starts. Resource. Everything you operate is a resource. Then you have the type of that resource. So type of this resource is going to be AWS Security Group. If you are into AWS, you know what is it. And if you aren't, easy to explain, like sec groups, security groups help you to configure, let's say, firewalls of AWS. So in this case,
think of it like really advanced firewall rules.
Yep. And this security group will be called SSH. It's just a name. And it will have AWS name, allow SSH. Notice that's a Terraform name. And that's AWS name because it's a property of the resource type AWS sec group. And then it has ingress for port 22. So that's an SSH port to make SSH connections. Protocol TCP, and allow it from everywhere without any IP limitations. Oops, sorry. When we have next AWS Security Group, very familiar. So notice it's exactly like the one above. The only different is port and the name. So this one is for HTTP. Idea is the same. And then finally we have the core, the most important, maybe most used resource, is type AWS instance name voting. It has AMI. Again, if you are into AWS, you know what is it. If you aren't, AMI is Amazon Machine Image. So then a base image we will use to spawn a new instance. Instance type will be t2.micro. So pretty small machine, we don't need too much. When we allocate this machine to those security groups. So in this case, we are setting the SSH and HTTP security groups for this machine. So it will be available via SSH and HTTP. We set the key name as AWS key pair, deployer, key name. And now notice, here we mention AWS security group.ssh.name. It means what we are referencing, a resource type AWS security group with the name SSH, or ID SSH, and its property called name. And let's find it. Type AWS security group, boom. Name or ID SSH, boom. And its name will be allow SSH. That's the property, and that's the ID in Terraform. Same for HTTP. Well then, why do we reference AWS key pair? It's not defined before. Answer is simple. If I would describe all my infrastructure in one single file, it should be a really big file. So what we prefer to have here is spread our infra over multiple files, and that's just one of them, just to make things simpler. So AWS key pair, public part of your key, is created just in another file, defined in another file. It has ID deployer, as you could guess, and we put name to this part, so AWS instance voting will have public part of my key configured, and I will be able to connect to it. Finally, we set up a connection part. And connection describes a way how we could connect to this machine during the provisioning step. And so it says we will have a user called core. And final step is provisioning. So we will use a provisioner type remote exec, and we will do some steps here. So docker run, just run an application we prepared for this demo. Now, very important thing. Many people don't understand where is the infrastructure as a code tools and where are the configuration management tools. I have a special slide regarding that in the end, but what I want to say now, I will say later, and I will repeat in the end. Do not try to replace configuration management with infrastructure as a code, and vice versa. They both are required. Terraform is an infrastructure as a management tool which doesn't replace your Ansible or Chef or Puppet or whatever you are using. It's to create infrastructure, but in the best case scenario, it's to provision it and prepare it and install required things, not with Terraform, but with configuration management tool. So in the perfect case scenario, this provisioner should not be here at all. So, and everything, all bootstrapping done with configuration management. Or if you have to, it should be as simple as, I don't know, install Puppet agent. That's it. Don't overdo that. Keep provisioning here at this site as simple as possible. And then finally, before we switch to the last commands, it's last things we need to learn before proceeding to a practical part. Terraform init we use to initialize a project, and you will see it in action, so it will be easier to explain what's going on. Terraform plan to overview changes what Terraform is going to do using your definitions, and Terraform apply to apply these changes, and finally Terraform destroy to clean up the workspace. Don't do it.
Actually feels a lot like Helm in a weird way.
Yeah.
From how you actually use it as a user.
Yeah, exactly. Helm is a little bit younger, so I would say it in opposite way.
True.
Yeah, but the main idea is the same. Init, plan, apply, destroy. There are some more commands, of course, but that's an introduction level workshop, so we will not make a deep dive. And my question is now, do you want demo? Because that's the perfect time for a demo. And I will switch to my console, and I have to clean it up a little bit, sorry. Good. And you know what? Actually, to stop hiding the code, I will move myself a little bit. Hi, Eric. Now I directly above you on top of the screen. Hope it will be fine. I'm a good neighbor, more or less. And we can start. So, can you see my screen? Is it good if the...
It's looking pretty good. I'm just looking on YouTube here real quick. Yeah, if you can maybe size it up one or two notches, that would be good.
One or two, okay. So give me a second then. Boom, 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 boom. Well, come on.
Got a comment in YouTube. Would be great if you could change the background.
What do you mean?
I'm not entirely sure there. Of the console screen. Oh, is it too dark to see on the screens? Yeah. Can we change the can we invert it so the text is dark and the background
never
is white?
tried. I always stayed on the dark green side. Actually, I have no idea how I term changes it.
Yeah, it's in view.
In view, okay.
Under the view tab. Oh, you just passed it right by edit. Yeah, there you go. And then oh goodness. All right, we might need to do this later, but yeah, I haven't done this in forever either.
Yeah, I don't know. That's actually the first time out of dozens of workshops people ask me to switch colors. Sorry. I'm not prepared and I'm not actually even sure if it really helps. We will make an experiment and maybe we will switch to widescreen. Okay, but anyway, it's time to jump in and see how it works. And as said, it all starts with Terraform init command, but before we will do it, let's take a look on what do I have here. Or better, you know, by the way, a little cleanup. Let me grab a second. It was the Visual Studio Code. So there are a few files we have to discuss, and give me a moment. I'm gonna exclude the second cloud today. I'm not sure if we have time for that, but you can do it on your own because all the exercises will be available for you to do, and we will be answering your questions at Discord. So let's take a look at the most important files here. First one is versions Terraform. It was not required before versions 0.13, but now it's required, and we describe important things here. First, Terraform, so that's a configuration for Terraform, and required version will be higher or equal to 0.13. I have 0.13.5 now. And then second point is required providers. First provider I'm going to use is AWS with a source of HashiCorp AWS, and second one I'm going to use is a DigitalOcean with source DigitalOcean. Very good question was asked, where do they come from and why it looks like that? Answer is simple. When you have 4,500 of different modules and around close to 1,000 of different providers, you definitely don't want to download them all at once. So that's the idea. Terraform installs only the essentials by default. And when you describe required providers, and then it will download required providers you need. That's the first file we work. Second file we work with is AWS Config. Here is a very simple thing defined. First I define the provider, AWS. It will use my private profile to, I will show it in a moment, how do you set up it to work with access key and secret key, and my default region will be Europe Central 1 because I'm located close to Europe Central 1. And the second, we create a resource, type AWS key pair. You've seen that already, aren't you? Name it deployer or with ID deployer, and that will be a public key of my machine, so I will be able to contact the machines we will create. And finally, that's an AWS instances. AWS instances is a simple file. It defines instances we are going to use. And that's how typical file looks like now. This file was updated in comparison with a slide you've seen recently. Beginning looks exactly the same, but connection now is a little bit bigger because we have to specify not only user, but also host. Notice the self-reference. As a host, we specify self, so this AWS instance, public IP, pretty interesting. And we also specify private key for the connection, so Terraform will know how to contact this node to provision it. Again, don't use Terraform for provisioning, that's only for demo purposes. And we are going to run some commands there. And some more resources, some more instances we are going to create. That's a nice demo application you will see working in some minutes. That's a simple demo voting application. Simple but microservice oriented and very interesting how it works. The front end putting messages into the queue and worker processing the messages from the queue and putting data into PostgreSQL, and then backend application, well, backend front-end application showing the results for you. And they all look exactly the same. For this purpose, it's perfectly fine, and they're running the same AMI code. The only difference between is the command they will run. So for some of them, we run commands like to run PostgreSQL, and for some of them, we will run Redis, and for front-end worker and result front-end, we run our own, well, not our own, but the community prepared application. And finally, last file to mention is AWS Security Groups. Those are all security groups used by those instances. Notice how they are referenced. So, for example, this SSH ID security group, and in instances we see what, for example, in the security groups we have AWS Security Group, ID, SSH, name, because security group here consumes the names of the groups we are going to use. And last thing, AWS Elastic Ip. So Elastic Ip is a type of resource which creates Elastic Ip for your instances. What's the point and why do we do it this way? If you use AWS, you already know. IP addresses your machines are getting automatically are ephemeral. After restart, they may change. If you want your service to be available all the time, you have to allocate Elastic Ip from a pool of Elastic IPs, and it will be, allocated to this machine as we see in this line. So we very simply create an Elastic IP. We don't care about the particular number, we just need an allocated IP address. And instance it will be allocated to is AWS instance voting ID. So we have it.
Kind of like a way to put a static IP on this without really putting a static IP on it.
Yeah, exactly. And that's the main set of resources for us to cover. There are some more, but those are essentials. And finally, how do you configure system to work using your credentials? Here you see you may specify AWS secret key and access key right here, and it works. But of course there should be the better ways, and sometimes I work with AWS directly. So I have to switch to my terminal and show you something. When we go to AWS folder, there will be some files. 3 of them have my credentials, so I will not show them, sorry. But there is a credentials demo file which has demo credentials, which is very easy to show. That's the profile name will be my profile, and AWS access key and AWS secret access key, define it like that. And remember, this my profile thing, that's exactly the point you need to have. In my credentials, I have multiple profiles, multiple groups, because I work with different accounts on AWS. And when I work with Terraform, as you can see in this file, I specify profile private. It means what I will use credentials from AWS credentials file part private. There are multiple sections. I will use section private. And I cannot show you the key and access key, but those just long numbers and characters, and doesn't matter. Okay, so we discussed it a lot. Now finally let's push some buttons and let's take a look. And what was the first command I asked we will do? As I told we will do. It was Terraform init. On the first initialization, you do it only once per process, once per project. It may take a couple of time because depending on the project, Terraform has to install proper plugins, providers, modules, and so on and so forth. I did that already to save some of your time, but well, technically that's exactly what you will see on Terraform init. Initializing the backend. Okay. Initializing provider plugins. As said in the required providers, I am using HashiCorp AWS and DigitalOcean. Okay. Then, what's important for us? Terraform has been successfully initialized, so all the modules are installed and we are ready to go. You may now begin working with Terraform. Try running Terraform plan to see any changes what are required for your infrastructure. All Terraform commands should now work. And now that's we will do exactly what's suggested by the system. So we will execute Terraform plan. What happens behind the scenes? First, refreshing Terraform state in memory prior to plan. That's a trick. As long as you have a couple of nodes on the production, it will be not so big deal. But when you have thousands of them, trying to compute what should be done and what should not be done is going to be a pretty long story. To avoid that, first Terraform creates kind of local copy of your state on the cloud you are working with. So let me scroll up a little bit. In memory, and this state will be used to calculate this plan. And finally, when the state was synced, in our case it's a very simple job because my account is empty, we may generate an execution plan. Execution plan has been generated and is shown below. Resource actions are indicated with the following symbols. Create. There are three kinds of possible actions: create, modify, delete, destroy. As I have empty account, we are obviously only going to create. And what we are going to create? The things what I defined in my configuration file. So let's take a look at this one. Aws Elastic Ip, database IP, will be created. Some of the properties we know and define in our configuration files. Some of the properties we don't care, and they are known after apply. So take a look. This Elastic IP obviously going to have a public IP, otherwise it makes no sense. But we don't know it at the planning phase, because it will be known only after apply. But it's not so important to us again, because we already can reference this resource if we need that. So every resource is possible to be referenced for others, and I already can use this IP address if I need to put it somewhere. It will be covered. Then there are some more result IPs and Elastic IP again. Finally, instances. Something we know because we defined them. Instance type will be T2 micro. Correct. And some things like, I don't know, private IP is not known yet, only AWS can tell us. We know already security group names because we create them. It goes the same for all the other instances, so I will not stop for them for too long. What interesting here to mention? Let me scroll a little bit more. Okay, so we are going to create a key pair. Key pair obviously needs to have a public key. That's a public part of my key, which will be uploaded to AWS by Terraform. So I don't have to care about that. That's a Terraform job. We create some security groups as you expected. And mostly that's it. For this demo, we don't need too much things. So overall plan: 14 to add, 0 to change, 0 to destroy. Very well. And now finally, the last warning is really important. You didn't specify a -out parameter to save this plan. So Terraform cannot guarantee what exactly these actions will be performed if Terraform apply is subsequently run. What does that mean? In short, I've spent some minutes talking about this Terraform plan as it was done. It means what if my colleague, it means what if Eric, hey Eric, It means what if Eric would change anything in the file definitions and I would push Terraform apply button right now, what would happen? I would apply not only changes I plan to do, but also changes which may be not finished yet. And it may lead to some problems. So another way to use that, and that's very recommended for production purposes when you work with critical infrastructure, is instead of Terraform plan, do Terraform plan-out and specify a name for this plan. So let's say it will be plan 1. Doesn't matter, pretty good name.
And that'll save the state of that plan as you had it, so I can be editing all day and it doesn't matter.
Yep, exactly. So, perfect. This plan was saved to plan 1. Now I can execute this plan. What is plan 1? It's just a file, so I can open this file. And, well, it's kind of binary, so it doesn't help me too much. But it's here, and Terraform knows what to do with that. And now I can say Terraform apply and give it this plan 1, or in my case I can simply say Terraform apply. For me it doesn't matter because I do hope what Eric didn't change anything on my laptop meanwhile.
Little do you know.
But yes, so in our case there will be no difference between Terraform apply and Terraform apply plan 1. In the multi-user infrastructure environment, where many people are going to use Terraform, you may want to cover things like that. Okay, so I'm running Terraform apply. And now, Eric, I would ask you, how do you think? Which instance, which resource will be created first? How do you think?
I would think a security group would be created first.
Very possible. Let's take a look how it will work. So first I have to say yes, because I didn't use auto approve, so I have to confirm my idea. And take a look, you are perfectly right. AWS
Security Group, yeah.
Security Group, and key pair, and Security Group, and Security Group, and Security Group. And that's everything what we started. By default, Terraform works in 10 parallel processes, but we have only 6 here. Why?
Let's see here. It works in parallel with 10. I was not aware of that. I'm not sure. So educate me, Alex.
Answer is simple. It can try to create more resources at this moment, but all the other resources has dependencies. You cannot create a node using security group before security group is created, because there is a dependency. And that's why it starts exactly with the security groups and key pairs, because they have no dependencies. They are independent. Freedom! And they don't have any lockdowns here, and that's why we start. And we see what happens. Key pair deployer and sec groups are created. Creation complete after 0 seconds. Key pair was pretty quick, and sec groups...
And all the instances start up right after that.
Exactly, and despite Terraform had a capacity for them to be created, it was never applied because we were not able to create them, so that's the next step. And now we can create our instances. And now you can guess what the last step will be to create elastic IPs, because in this graph of dependencies, those are the latest, because Elastic IP needs nodes to be created, and nodes need security groups and key pairs to be created.
Right.
And this calculation was done completely without me doing that, just by Terraform. Thank you, Terraform. I love tools doing my work. So, creation is done after 10, 20, 30 seconds. Stop, still creating, yeah. But now it's a remote exec part, that's a provision step. Now we are trying to connect to the hosts, and first connection was done pretty quickly. We managed to connect Redis instance, and now this remote exec works, and our remote exec consists of only one command, which is docker run. So we can find Redis here, and it will just docker run detached open port Redis. Very well. So at first it's going to pull the Redis image, download complete, extract, and it will run it in the end. And then the same things are happening with ours. But again, notice we first start Redis and only then we start voting. Because voting for work needs what? Voting for work needs to know the Redis private IP. So there are more dependencies covered by Terraform. So, okay, some more work. Connected, pulling. Extracting, so there are provisioning going on in behind. For 5 images we are running. For 5 nodes we are running, sorry. And is it done already? I have no idea why the output looks like that. Really have no idea. Good.
Yeah, a bunch of new line characters just get thrown in.
So
Error. Uh-oh.
One application failed to start. That's curious. I guess I know what happened, but it will be easy to fix. So let's take a look at the first thing I want to see. Let's ask for Terraform plan. Want to add. I guess. Okay, worker is tainted, so must be replaced. Something happened with the worker. That's interesting because I did this workshop exactly a few hours ago and it didn't happen. But well, cloud environments are pretty hostile, so no surprises. First thing I'm going to do is just to repeat Terraform apply. It will basically replace the existing worker instance. Others will not be changed. Okay, so meanwhile, it takes some time. We can go and take a look at the nodes I'm going to have here. So that's my AWS interface, and I'm going to have some instances here. And one should be old, I guess.
These all look pretty consistent.
They all look pretty old, which is a bit weird because I'm absolutely sure I terminated them before. So launch time looks a bit weird to me. Interesting. But okay, so one is from another workshop and 5 are those. And also we have some Elastic IP addresses. Let me renew a page. Good. And I try to open those IP addresses and see if we have anything here. So if worker is down, there will be not so much things to use, but we can try. And at least 2 of them in general should answer, at least 1 of them to be more specific. Okay, that looks better already. And finally, this one then I guess is a front end. Okay. Shit happens. Let me take a look. But this node was recreated, so now it should be fine. And now I can take a look at what exactly happening with my machines, as I have 5 of them. And this one looks good, so we have some results already. But those 2 are interesting to me, so I want to take a look at what's going on. As I've created an SSH key for them, it's going to be pretty easy to contact them. I need to know the username of those machines, or how do I contact them. I have to clean up the HTTP part, of course, and I will use this IP address. Okay, and as I run everything in Docker, I see, but why 4 hours ago? That's what completely not...
Yeah, this is all from the old workshop.
Yeah, that's for... I mean, that explains a lot. Okay, they are basically exactly the same. But I was perfectly sure I terminated them. That makes me very curious on how come we have them again. Because that's definitely Europe Central 1. So that's my region, and those are the instances I've created. Okay, you know what? To make it easier, I will say Terraform Destroy. I was intended to do it in the end, but it looks like it's a good moment to do a little cleanup. Yes, I want to clean up. Okay, at least now you see it's a live demo, not a recording. Any interesting questions, Eric?
So far the chats look pretty clear.
That I will hope it means what my explanations are good. And
yeah, either that or everyone's waiting with bated breath to see what happens here.
Yeah, well, I do, because that's interesting. How come?
Destruction complete. Destruction. Okay.
I guess I know what's the point. I changed this part of the config of the connection part recently, and I guess I used wrong profile. It should have been not private, but another one. So I guess I'm on a wrong AWS resource, wrong AWS account. That would explain everything. So destruction complete. That's good. And are we done? Almost. Still destroying Postgres. That sounds creepy a little bit. So don't destroy Postgres, it's not so bad.
Yeah, always get nervous when you see a database being destroyed.
Well, of course, definitely not with production. But for production, by the way, as we are waiting anyway for the destroying process to be done, I will give you a little nice advice. When you create an instance on AWS, you may have a special button here which is kinda disable API termination. That means what instance cannot be configured, cannot be deleted. I enable termination protection. Protect against accidental termination. Of course, you can configure this step with Terraform as well, and it saved a lot of people from some problems before, and I suggest you to consider this kind of things. Okay, still destroying. And I bet now we can switch and see. I bet it was a wrong account. That would explain everything. Okay. And also I have to hide my screen for a second because I have to check a moment.
Okay.
Okay, so how it goes? Still destroying. Okay. Anyway, no worries, because I'm getting ready to spawn the machines. There they should be spawned.
And to be fair, like if I were doing this all on my own data center on-prem and I was setting up these servers myself and everything, we're talking about doing a couple days worth of work probably here in 1 or 2 commands.
Yeah. Well,
so that's kind of incredible.
Yeah, that's incredible, but from another point of view, when you run those commands, they have to be configured and oops, sorry. And someone has to write the file, and I spent some time writing those before. Okay, now it should be fine. And if I see those instances, I guess they will be still here, and it makes perfect sense. Yeah, instance running. Okay, so I'm to stop this process. That's the wrong. Okay, destroy complete. That's nice. And now we can say Terraform plan. I've switched meanwhile. Okay, 11 to add, so multiple resources are running. Now I hope what we are going to add. Seg group redis, seg group okay, pair. We are going to add worker, and voting will be created, and result will be created, and redis will be created, and db. So it looks good. It looks good. Then I can start to apply this. That means don't switch accounts in the middle of a process. Yes, that's what I want to do. Okay, running. Good. So hopefully now I will have accounts I needed to have. I will use account I needed to use, and we have these EC2 instances available. And you've seen some leftovers of the last workshop, but that's perfectly fine. And while they are creating, I want to talk a little bit about one more file, one more resource kind, which might have a lot of important meaning to you. I will put it right here, and we will talk how it works. There is one more resource which is important for us, called output. The point is, when you work with a lot of instances that's sometimes very hard to discuss, very hard to understand what you are going to use and which IP were allocated and so on and so forth. So instead of digging into the state of the Terraform files or trying to find it on your own, you can simply define output. And this output, like a variable, will be called AWS voting IP and AWS result IP, and the value will be AWS Elastic IP. I think you know what I'm going to say. Voting IP, public IP property. So that's the type, that's the ID, and that's what property we are going to use. And if we get a little bit higher, we see indeed what we have. Resource AWS Elastic IP matching, voting IP matching, and it has instance allocated, and we will have this public IP in output. I added that too late, but we have our resources added. And we can say Terraform, oops, I was too quick, Terraform, so okay, what we have right now, that's our state. And if I say Terraform plan, we will have nothing to plan because all changes were executed. And okay, as we have added outputs, you see there is a new consequence, changes to output, AWS result IP, AWS voting IP. Now I can grab those IPs, go to my browser and open them. Okay, so voting is just starting. And you know what? I have to go to YouTube and put those address into the YouTube. So that's going to be the result page. And oops, sorry. And this one is going to be voting IP. And there is a very simple vote when we can decide between cats and dogs. And as soon as you start to push the buttons, I hope. So there is my vote. It's getting closer and closer. Incredible. Yes, I see. So someone is voting already. Very good. I have no idea why voting part starts so slowly today. Really, it both very slow this workshop and one before. Usually it works pretty quick. I maybe have to investigate that. But we see what people are pushing buttons, so you can go and push the button and see how it changes. And as I'm the cat person, I will push the cat button and we can see how it goes on the back end, and it changes indeed. So, Eric, would you please push a button and wait for a moment?
I was the one who voted dogs.
So, you can for a moment switch for cats, just for the demo purposes.
Okay.
Yeah.
Go ahead and click that here.
Okay. Yeah, application works slow today.
Yeah, it's a little bit slow, but that's okay.
But that's okay indeed. Okay. And oh, that's the old one from today's. Okay, then if I switch to docs. Okay, yeah, I see now it's changing. So someone is helping us. We have 3 people voted, which is nice. And finally, so we can walk through all the resources created. We have nodes created, instances. We have Elastic IPs as discussed. And we have also security groups created. Where is my sec groups? Here we go. So at least most of those security groups were created and managed by Terraform, as you see in the description. That's nice. And final command I want to show, and actually I've shown already, is Terraform Destroy. And you know what? I don't want to put just Terraform Destroy because I did that already for you, so you've seen how it works. Let's better talk about AWS instances, what I can change. I can, for example, close the voting, you know, by removing this instance. So now it's wiped, and I'm going to say Terraform apply. Oh, of course. So that's also error handling from Terraform. I can remove voting instance, but it has a reference. The Elastic IP has a reference to a voting IP, and therefore I have to remove this Elastic IP for voting IP. And also this one then will be, this output will be also redundant. So now I can say again Terraform apply. Okay, 0 to add, 0 to change, 2 to destroy. And output will be changed as well, but it doesn't count like real change. So it will take a moment to destroy this instance, and then therefore to destroy, well, not destroy, but remove this Elastic IP allocated before. And that's the general idea how it works. So let's switch then, because I have a couple of more slides to talk while it's being cleaned up. Speaking of infrastructure as a code, we have some new features. Better observability, as you don't have to jump from one availability zone to another looking for your servers. You have everything in files, but also you have a very high, better traceability, because when you have infrastructure as a code, you may use even it with Git, and I can completely suggest you to use it with Git, because it really helps when you have or automation or culture to always combine it. It will be very good to work together, so you always see what changes were done to your infrastructure, when it was done, who did that, which ticket it related to, ability to keep your servers closely related to the tickets you are doing. That's great, because I may say what this change set was done due to Jira issue number whatever 1518. When fast deployment, I can say what the, I don't know why AWS Route 53, so DNS server, is so slow. But if we create literally hundreds of nodes without a need to create hundreds or thousands of resource records, so subdomains, it may take, I don't know, 15 minutes, because we do it on a high parallelism, so a lot of queries simultaneously, and deployment can be really, really fast and removing well as well. Reproducibility, you can have the same infrastructure spawned over multiple accounts many times, and that really, really helps. So if you want to have multiple type of servers of the same type, and it always to be the same, so avoid some floating bugs, that's a very good thing. And also kinda a rollback capability. You added some servers, Terraform apply, git commit, git push. Now you see what you don't need that, or something happened, you want to revert that. You can absolutely revert this deployment with just rollback, this commit and Terraform apply. Server definitions are missing in the files. So Terraform will put it back to the previous state, removing newly created servers. That's lovely. And few last words. And forewarned is forearmed. There are no silver bullets in software development, and there are some issues to cover. Terraform has over 6,000 forks, almost 25,000 stars, and almost 1,500 contributors on GitHub. It's still in development. The latest stable version considered to be 0.13.5, and that's a 6 years old project, and I know many companies using it in production. But should you use it in production? That's not for me to decide. Then second point, very well said by Henrik Barcelos. If you don't understand how AWS works, Terraform will not make your life easier. Indeed, it might make it worse. Terraform is a great automation tool, but it's not an abstraction layer. So it means what you still need to understand how these levels down are working, and if you try to use Terraform with the backends you don't understand how they work, you definitely may run into troubles. Then Terraform definitions are cloud specific. That's not clear if we have to call that as cloud agnostic, vendor agnostic or not. As said, there are a lot of different opinions on that, but that's what's important. Terraform definitions are cloud specific. Take a look. We were working with AWS instances, and they all are AWS instance, AWS AMI, AWS instance type, and so on and so forth. But if we switch to DigitalOcean, which is another cloud provider not so famous as AWS, and we see DigitalOcean instances definitions, we have DigitalOcean droplets, we see image, not AMI, we see size, not instance type, and some more differences. And that's important to understand. They may look the same, but they are not the same. They have different APIs, and there is no abstraction layer. You cannot create one generic instance and then ask Terraform to create it on Terraform, on AWS, GCP, DigitalOcean, and so on and so forth. That doesn't work this way. You need to know and understand API for every of the providers you are using. And last one. State update may be very slow on large infrastructures. I don't know, maybe it's solved already in the upcoming versions, but at least a couple of years ago for the large infrastructures, state update process, so commands like Terraform apply, Terraform plan, could take an ages, and the only way to avoid that was to isolate Terraform projects into multiple minor projects. So you have to run the commands from different places, which is not convenient, but at least they are to be executed quickly. And finally, one more time. Infrastructure as a code tools are not configuration management tools, and opposite. Configuration management is not to replace infrastructure as a code, and infrastructure as a code is not to replace configuration management. They are to perfectly work together. You need to do the management and install of applications and configuration management with a proper tool like Ansible, Chef, Puppet, or whatever you prefer in this field. Thank you. We are done for today. Eric, thank you so much for staying with us.
Absolutely.
Yeah, and I'm afraid we are out of time. We will try to answer some questions if we get any. But over my words,
looks like we're pretty clear in the chats, so we should be good to go.
Lovely. So thank you everyone for joining us. That's a big pleasure to see you again. Don't forget, in 2 weeks we have a very nice talk about Ceph distributed storage system, so you can see how it works, why it works this way, and why you may need that for which kind of projects. And that was it for today. So I see no new questions. Perfect. No voucher code today. Hey, John, I believe you got already a couple of them. But important thing, voucher code, you don't need anymore to attend a workshop to get a voucher. Just pass the course and you get your voucher. So get the course at the Academy and you don't need anything else. You will get your voucher and you will pass the exam.
Yep, basically if you do the pre-work, we give you the voucher.
Good. So thank you all for attending the workshop. It was a big pleasure. And hope you liked that. Don't forget to subscribe. There is a subscribe button directly under Eric. And we have more events coming up in the next week. So stay tuned and thank you for being with us. It was Aleksandr VOLOCHNEV and Erick ZIETLOW, and we are really happy to have it all running with you.
All right, we'll see you next time.
See you next time.